Welcome to Arrays and Panel Grouping Concepts. This module covers how solar panels are organized into groups and why that organization matters for your inspections. Understanding array structure helps you evaluate shading, verify panel counts, and interpret production data accurately. Let's start with the basic hierarchy. A cell is the smallest unit, a single photovoltaic cell that generates a tiny amount of electricity. A module, which we commonly call a solar panel, is multiple cells wired together in a frame, and an array is all the panels at the property, the complete solar installation. So when someone says the array, they mean every panel on the roof, taken as a whole. Within an array, panels are often grouped into strings. A string is a group of panels wired in series, meaning positive to negative in a chain. In a series connection, voltage adds up. For example, 6 panels each producing 40 volts equals 240 volts DC at the inverter input. Current, or amps, stays the same throughout the string. The critical thing to understand is that the weakest panel limits the entire string. If one panel is shaded, damaged, or dirty, it reduces the output of every panel in that string. Larger systems often have multiple strings, sometimes on different roof faces or orientations. For example, a home might have string 1 on the south roof with 8 panels, string 2 on the east roof with 4 panels, and string 3 on the west roof with 4 more panels. Each string connects to a separate MPPT input on the inverter. MPPT stands for Maximum Power Point Tracking. It allows the inverter to optimize each string independently, which is important when strings face different directions. Why does all this matter for your inspections? First, shading affects strings differently. A tree shading the south string doesn't affect the east string, so evaluate each string's sun exposure separately. Second, panel count affects expected output. More panels means higher expected production, so verify the count matches the permit documents. Third, orientation affects when production peaks. East-facing panels peak in the morning, west-facing in the afternoon. And fourth, tilt affects annual yield. Panels at the optimal tilt for the location produce more than flat or steeply mounted panels. SolarCheck Pro accounts for orientation and tilt when calculating expected versus actual performance. Here are the key takeaways for this module and for Section 1 as a whole. An array is all panels at the property. A string is panels wired in series. Voltage adds up, current stays the same. Multiple strings are common on larger or multi-roof systems. Shading one panel reduces the whole string. Always evaluate each string's exposure. And orientation and tilt affect production timing and annual yield. That wraps up Section 1, Solar Fundamentals. You now have the foundational knowledge to understand what you're looking at in the field. Section 2 will take you into the SolarCheck Pro app itself.